This is the chapter review sheet. Some of this we would have covered in class, so fast forward if you need to, or rewatch if you need to do that. Um, the terms fill in the blank. I skipped quite a few of these just because they weren't terms that I dealt with. But do make sure you study your flashcards, as not all of the terms were covered in this brief review here. A blank is a rectangular arrangement of numbers in rows and columns. That's a matrix. Each element or each part of that is called an element. Number 4, this is showing the distributive property. Number 5, to change the order of the add-ins, the thing being added. And I need another parentheses there. We will use the commutative property. So when you rearrange the things, it's the commutative property. Number 7, the blank of an event is all the outcomes that are not in the event. That is called the complement of the event. You select a card, replace it, then select another card. This is an independent event because when you replace the card, that means that the second event is not affected by the first event. And again, study those flashcards. And then moving on to the simplifying part here, I find my first number. Immediately after it is a plus sign, so this is an addition problem. So the signs are the same if you're using that visual. They're both here, so I am going to add them and keep the sign. Number 12, I find my first number. Immediately after it is a minus sign, so this is a subtraction problem. So I am going to change the sign of my number and add. I will make those 2 marks. That gives me then a positive 7 and a negative 12. The signs are different, so I find the difference and keep the sign of the larger. Number 13, find the first number. Immediately after it is a plus sign, so this is an addition problem. The signs are different. I have 22.3 and 12.4, so I need to find the difference. And I do want to see this work. Gonna have to borrow there. That's a 9. 11 minus 2 is 9. So we end up with 9.9, and it would be positive because the larger number is positive. On this one, we're going to take our 54.3 and subtract 29.4 first. So we're going to borrow from that 4 and make it a 3. 13 minus 4 is 9. Borrow from the 5, make it a 4. We have 13 minus 9 is 4. And then 4 minus 2 is 2. That is inside the absolute value. And then that will come out as a positive because remember, absolute value is distance, so it's always positive. Looking at this one, find the first number. Immediately after it is a subtraction sign, so this is a subtraction problem. So I will change the sign of my number and add. So I made those 2 marks. And making that 17 a negative, the 5 is positive, the signs are different. They're on opposite sides there, so I need to find the difference and keep the sign of the larger. On this one, this would be negative 3 times 3, because we would do the squared first and then change the sign, plus negative 3 times negative 3. So I'm going to have 3 times 3 is 9, and it would be negative, plus negative 3 times negative 3 is a positive 9, so I get 0 there. Again, I do want to see that work there. Not just negative 9 plus 9. Show me that separation of those there. Inside my absolute value, find the first number. Immediately after it is a subtraction sign, so this is a subtraction problem. I'm going to change my sign and add. And so inside the absolute value, I'm going to have negative 14 because the 5 and 9 are both negative. So I'm going to add them and keep the sign, and then that would come out as a positive 14. Letter B is also a subtraction problem, and I know that because find the first number, immediately after it is a subtraction sign. Make my 2 marks, change my sign and add. That gives me a -2 and a +5. They're on opposite sides, so I find the difference and keep the sign of the larger. Letter C, I need a common denominator, so for 3 and 4, it's going to be 12. So I'm going to multiply that one by 3 over 3 and this one by 4 over 4. So -4/12. Don't lose that negative there. I'll try and give you a little more room on yours. And so looking at just the numerators, their signs are opposite, so I find the difference and keep the sign of the larger. So I'm going to have -1/12. Show your common denominator fractions. Here, 4, so I'm going to change my sign and add. First, I need to do the multiplication. -3 times -2 is a +6, and so that would give me 10. And then on this one, 4 times 5 is 20, times -2 would be -40. Number 19 may look like a subtraction problem, but if you find the first number, the first thing immediately after it is that beginning parentheses on the next number. That indicates multiplication. So this is a multiplication problem. So 5 times, oh, I can reduce. 2 will go into 6 3 times. So 5 times 1 is 5, 3 times 3 is 9, positive times a negative is a negative. So I have -5/9. On this one, I need to do the top of my fraction first. That serves as a grouping symbol. So I changed my sign and added, and I get 6 over 3, which would be 2. Here, division, we need to invert and multiply. So we're going to invert our second fraction. 3 will go into 6 2 times. So we have 5 times 1 is 5. 2 times 2 is 4. You can leave it as an improper fraction. If you did it as a mixed number, it would be 1 and 1/4, -1 and 1/4. And then on this one, we have to square this first. We have to do our exponent first before we can divide. So 5 6 divided by -2/3 times -2/3, which is going to be 5 6 divided by +4/9. Now I can invert and multiply. And 6 and 9 are both divisible by 3. So 5 times 3 is 15. 2 times 4 is 8. Again, you may leave that as an improper fraction. If you wrote it as a mixed number, it would be 1 and 7/8. Moving on, we are simplifying by either using the distributive property or combining like terms or some combination of both. So here's like terms here. 9m and -5m would be 4m, and then that +3 is still there. On 24, the 2b and the -2b would give me 1b left, because remember that's -1b. And then we have 8 plus 2, they're both positive, so that would be 10. On this one, we're going to use the distributive property. -5 times w is -5w. -5 times a -4 is a +20. This is what I did to get that. 9 times 4 is 36. 9 times -3j is -27j. Again, this is what I did to get that. Negative times 3 would be -3. Negative times negative 10y would be positive 10y. If you see a negative out front, it's going to change the signs of everything inside. Negative times 2 is negative 2r. Negative 2 times negative 1/2. You can see here, that's over 1. That will cancel. Negative times a negative becomes positive, so we have plus 1. 5 times 7b is 35b. And then 5 times positive 1 is plus 5. On this one, my like terms are a negative 7 and a negative 9, or negative 16 and negative 9. So we have negative 25v. You can put the 7 in the front, or if you are used to writing your numbers first or your variables first, that's how it would look. Either one is fine. So 3/5 times 15t. We can write that over 1. So 5 will go into 15 3 times. So that would give me 9t minus plus 3/5 times negative 2. Again, putting that over 1, I'm going to get minus 6/5. And you could leave it as an improper fraction. If you did not want to, it would be 9t minus 1 and 1/5 as a mixed number. On this one, negative 3 times positive 6 is negative 18. Negative 3 times negative 3m is positive 9m. This is a negative 1 times 4 would be negative 4. Negative 1 times negative x would be positive x. 20 times 0.5, which is a half, by the way. 0, 10, so we get 10g. But just in case you didn't recognize that as a half, 3 times 0.5, 3 times 5 is 15, and I need 1 decimal place. This section, we're telling the number properties. On this one, you'll notice 62, 15, 38, 62, 15, 38. The numbers did not change order. What changed was my groupings. This is the associative. And it's addition. So make sure you have that addition part with it. Here, 62 plus 0 equals 15 plus 38 in parentheses. What has changed is that has become 62. And that is the identity property of addition, where we start and stop with the same number. I started with 62 and I ended with 62. Here, 50, 17, 2, 52, 17. The order of the numbers has changed. That's the commutative. And it is multiplication. On this one, they took the 9 through. That's the distributive property. And I would, on 36, I would underline this and this to show yourself how I was coming up with the identity property from all of that. On letter A here, 235, 235, the numbers have not changed their location. The grouping has changed. So that's the associative of multiplication. Letter B, 235, 253, the order has changed. That's commutative. If you change the order, it's the commutative property. And that's also multiplication. 2 times 1/2 equals 2. This is the inverse property of multiplication. And I think I said that wrong. 2 times 1/2 equals 1. I have no idea what I said when I said that a minute ago. 5 plus negative 5 equals 0. This is the inverse property of addition. The inverse property ends with 1 or 0. For multiplication, it ends with 1. For addition, it ends with 0. 5 times 1 equals 5. We start and stop with the same thing. So this is the identity property and its multiplication. And then 12 times 0 equals 0. This is the 0 property of multiplication. I did not put on here the symmetric property. The symmetric property would be like if x equals 3, then 3 equals x. Okay, moving on to these, simplifying them, I'm going to start by multiplying 56 by 1 over 56. Well, that 56 is just 56 over 1. So that will give me 19 plus 1, which would be 20. Here, negative 12p and a negative 7p. Two negatives, add them up, keep the sign. So negative 19p plus 45. 41, we're going to use the distributive property first. Get 14 minus 2v, and then that minus 3v is still there. And then if you need to do that to see that it's a negative 3v, I have combining like terms, these two, 2 and 3, both negative. So I have the 14. It doesn't have any like terms. Minus 5v. You could also write that as 14 plus a negative 5v. That would be the same thing. On 20 or 42, what they're checking here is do you recognize that these are like terms? The definition of like terms is that they have the same letters with the same exponents, a, b, and c. Here they are, a, b, and c. So they have the same letters and same exponents. The letters are just in a different order, but they are like terms. So we have 24 of those minus 24 of those. So we have none of those. On this one, let's rearrange things. Do go ahead and show your rearrangement. So we're going to have 4 times 25 is 100, and 13 times 1 is 13. And so this is going to be 1300. Here, 4 outside I can't do anything with. And it looks like I'm missing a parentheses there. Or I have an extra parentheses. I have an extra parentheses. That's not there. So let's take that 2 through, and it's going to be a negative 2. I'm going to change my sign and add. So negative 2 times 2m is negative 4m. Negative 2 times 3 is negative 6. Combine like terms. Negative 3m minus 6. And then we get to use the distributive property again. 4 times negative 3m is negative 12m. And 4 times negative 6 is negative 24. And then we hit probability. Give the probability in reduced fraction if you roll a standard 6-sided die. What's the probability that you get a number equal to 7? There are none of them, so it would be 0. A number that's not 5, well, that would be 5 out of the 6 aren't 5. That would be 1, 2, 3, 4, and 6. 2 or 6, that would be 2 out of the 6, which would reduce to 1/3. Probability of getting a 3 would be 1 out of 6. The probability of getting a number less than 6 would be 1, 2, 3, 4, and 5. So that would be 5 out of the 6. And the probability of not getting an odd would be the evens. So that would be 3 out of the 6. Or you could say 1 minus 3, 6. Do your complement. That would give you 3/6, which would be 1/2. On this, we have a standard spinner. We are giving odds as a reduced ratio. The odds in favor of 1 So that would be 1 out of how many are left? 7 left. So again, when we do odds, it's the one we're interested in compared to the others, not the total. The odds against even. Well, there are 4 evens and there are 4 that aren't even. So it's a 1-to-1 odds. Odds in favor of green. There are 3 that are green and 5 that aren't green. So again, are you catching the difference? With probability, it's out of the total. With odds, it's a comparison between what I'm looking at and what's left. Odds against red. Well, there are 6 that are not red and 2 that are red. And so this would be a 3-to-1 ratio. Odds in favor of a multiple of 3. So your multiples of 3 are 3 and 6 in this grouping. So that's 2 of them. The other 6 are not multiples of 3. This will reduce to 1-to-3. A factor of 6, the factors of 6 are 1 and 6, 2 and 3. So I want the odds against that. Well, that's 4 of them. There's 4 others. And then that's those 4. And that'll reduce to a 1-to-1. And this section we had to tell whether it was an independent or dependent event. If you do not replace the card, it's dependent because one thing affects the other. The second pull is dependent upon the first pull. It depends on what you pulled in the first one. So you've got numbers 1 through 10. On the first pull, you pull a 6, and there's only one 6 in there. You do not replace the card, so there's only 9 cards left. And how many of those would be even? Well, let's look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But we pulled the 6 out. So 1, 2, 3, 4 more are even. And so that will reduce to 1 over 5 times 2 over 9. And so we end up with 2 over 45 and show that fraction there. Probability of pulling a 1 and then an odd number, but you do replace the card, so it's independent. One pull doesn't affect the other one. So there's 1 out of 10. You replace the card, so there's still 10 cards left. How many of those are odds? Well, 5 of them. 1, 3, 5, 7, and 9. And so reducing, we get 1/20th. The probability of an even and then an odd without replacing. So since you don't replace one pull affects the other one, so it's dependent. So the even numbers, there's 5 of them, 2, 4, 6, 8, and 10. And when you're done, let's say you pulled the 6, there's 9 cards left. 5 of those are odd. So we're going to get 5 out of 18 as our probability there. Probability of an even and an odd with replacing the card. So since you replaced it, one event doesn't affect the other. So you have 5 out of 10 even. You put the card back. You still have 5 out of 10 odd. These will both reduce to 1/2, which is 1/4. Probability of getting a 5, which would be 1 out of 10. And then an even without replacing. So since you did not replace, one event affects the other. And you didn't replace, so there's only 9 cards left. You pulled out a 5. So up here, the 6 is still in here. The 5 is not. So you still have 1, 2, 3, 4, 5 even numbers. 5 will go into 10 2 times, so we end up with 1 out of 18 there. And then some from the chapter review. On these matrices, your answer is a matrix. So 1/5 time or plus 4 is just 4 and 1/5. That was pretty easy. -2 plus a -1/2. They're both negative, so I can add them together and keep the sign. I get -2.5. 0 plus a -5 is -5. And then 4/9 plus 4/9. When we add fractions, we add the numerator and keep the denominator. So we get 8/9. Number 11, you had to look at page 112. It said on 4 plays, a team gained 22 yards, lost 18. That's not very neat. Gained 8 and lost 14. What's the total? So what we need to do is go through here. And so we have positive 22 and 8, negative 18 and 14. I'm going to right there go ahead and total those up. That's a total of 32 there and 30 here. And so they're on opposite sides. So we find the difference and keep the sign of the larger. So -2. So they lost 2 yards. And then number 12, Marcus had 163 in his checking account. On Monday, he wrote a check for 315. How much does Marcus need to deposit into his account to prevent the account balance from dipping below the minimum of $25? So he had 163. He wrote a check for 315. So that's going to give me a negative balance. And I am needing to subtract there. 2 of $152. So not only does he need to deposit $152 to make up for the fact that he's in the red, he also has to put in $25 because he has to have a minimum balance. So he has to deposit $177 to make up for the negative and get him into the positive. In this section, we're evaluating, so we want to show our substitution. 3x would be 3 times x plus, or sorry, 2x would be 2 times x. X is 3. 3 times -1 plus z is 2. So doing order of operations, doing my multiplication, and then doing addition, subtraction from left to right. 6 plus a -3 is 3, plus 2 would be 5. Here, x is 3, y is -1, minus 3 times z was 2 over -5. Need to clean up the top of the fraction first. Change my sign in adding. I get -9 over -5, which would just be 9/5. Negative divided by a positive is positive. So 9/5 as an improper or as a mixed number, it would be 1 4/5. You would get that by taking the 9 and dividing it by the 5. And that's how you get your 4/5. There's your numerator, there's your denominator of your fractions. And then here, the absolute value of -1 minus 3 minus 2. So dealing with inside the absolute value first, because it serves as a grouping symbol. I'm going to have a -4 inside that absolute value. It will come out as 4. 4 minus 2 is 2. X squared plus -x squared. So we end up with 3 squared, which is 9. I'm going to go ahead and show you that. 3 squared is 3 times 3. This is -3 times -3. So we end up with 9 plus 9, or 18.